Welcome back. Let's do another example, this time involving three sets. So we've got sets A, B, and C, and we'd like to describe who has been shaded. If it's just one shaded region, then we can use the same technique that we used previously, which is to describe where are we in terms of all the sets. So for the first one in part A, if I were to describe this, you're definitely inside of A. The shaded area, it's not inside of B. The shaded area, it's also not inside of C. So if I were describing where are we, I would say we are inside of A, and at the same time, which is an intersection, we are not inside of B. So B complement, the opposite of B. And at the same time, we're not inside of C, the opposite of C, C complement. And I can do the same thing for the second one, which again, it's only one little shaded region. I could say, well, this is the parts that are inside of A, and at the same time, the shaded region is inside of B, and at the same time, what we've shaded is not inside of C. So I would say this is A intersect B intersect C complement. All right, let's do the next two. And now for these ones, we've got more than one region shaded. So sometimes it might be possible to come up with a nice compact way to describe it. And it might be possible, even though there's A's, B's, and C's in this picture, that what I've got shaded might not involve A, B, and also C. So there is one easy answer for this picture, for this Venn diagram, and that would be to say that what's been shaded here, if you were to describe the two areas that have been shaded together, you would say those are all the areas in that Venn diagram where B and C overlap. So one correct answer that you could give for this would be to say that we are in B intersect C. Because if I said, where do B and C overlap? Well, there's the very center, that's part of it. B and C are overlapping there. That includes some of A as well. You'd also have B and C overlapping in the second part, which doesn't include any of A. So you might be saying to yourself, don't I need to mention A in this at all? And the answer is, no, you don't have to. So when I say B intersects C, those would be all the parts where B and C overlap, whether or not you happen to be inside of A. Since A isn't mentioned here, then I don't have to narrow it down to parts that are inside of A or not inside of A. So that is one answer. And so if you did notice that the little overlap here is B intersect C, then good for you. But if you didn't, there is another way to do this, and this way will always work. It gives you an expression that's a little bit longer and a little messier looking, but it always works just fine. And that's to describe each of the shaded regions separately. So here I've got two shaded regions, and if I wanted to describe them, if I wanted to say, what have we shaded? I could say, well, you've shaded region 1, or you've shaded region 2. So in other words, in terms of symbols, remember or is a union. So in other words, I'm shading all of region 1 together with all of region 2, and that would give me those two areas shaded together. So now I just need to describe, how do I describe region 1? So region 1, that's the very middle. That's inside of A, and it's also inside of B, and it's also inside of C. Region 2, if I were describing where is that, I'd say, well, that's not inside of A, but it is inside of B, so and inside of B, and it's also inside of C as well. So both of these would be correct answers. You'll notice one's a lot more compact than the other, but both are equally correct. And the good news is this second approach will always work. So no matter how many regions you have, you could just say you're in region 1, union region 2, union region 3, union, 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 and then describe each of those individual regions in terms of being in or out of A, B, and C. So that's the approach that I'm going to use here for part D. I don't think there's a nice compact way to describe D. Instead, I'm going to say, well, we've got three shaded regions. So if I were describing part D, I would say you're either in region 1, or you're in region 2, or you're in region 3. And I have a feeling I'm probably going to need more room, so try that again. So region 1, or region 2, or region 3. Region 1, so if I were describing region 1, I would say you're inside of A, and you are not inside of B, and you are inside of C. Region 2, what's going on there? Well, that's only inside of C. You are not inside of A, and you are not inside of B, and you are inside of C. That third region, if I were describing where are you? Well, you're only inside of B, so you are not inside of A, and you are inside of B, and you are not inside of C. So the first region, you're in A, you're in C, you're not inside of B. The second region, you're only in C, you're not inside of A, you're not inside of B. The third region, you're only in B, you're not inside of A, you're not inside of C, and you're either in region 1, or you're in region 2, or you're in region 3. So this long, nasty expression describes all 3 shaded regions. Okay, let's do another example, this time the reverse. So we've got ourselves an expression, and we would need to come up with the shaded regions. So I'm going to first divvy this up into little parts. If I wanted to find that whole expression A union B intersect, A union C intersect B complement, I'll need to know where A union C is. I'll need to know where B complement is, and then I can do the intersection as my last step. So A union C intersected with B complement. So let's start shading. Let's A union C, anybody who's inside of A or C or both. So all of this, that's all of A. And now I'm going to add in the parts of C that I didn't already shade. So there's 1, 2, 3, 4, 5, 6 regions inside of A union C. B complement. B, there's 4 things that are part of B, and that means there are 4 things that are not inside of B. So the only inside of A, the only inside of C, the only inside of A and C, and then also the exterior. And there we go, we've shaded B complement. And then finally, we're looking for A union C intersected with B complement. So now an intersection is an overlap, what they have in common. And if I'm looking at my 2 diagrams and I'm looking at all of the 1, 2, 3, 4, 5, 6 regions in the first diagram, I can see that 3 of them happen to be shaded in the second diagram. The only A by itself got shaded for both. The just inside of A and C, not including B, was shaded for both. The only inside of C, not including A, not including B, that was shaded for both. And everything else was either shaded once or wasn't shaded at all on either diagram, so that'll be unshaded for our last picture. Okay, next one's a little bit more involved. So we have a bunch of steps for this one to think about. First, if I'm looking at A intersect B union B intersect C complement, I'll need to figure out that first bracket, A intersect B. And then for that second bracket, before I can find B intersect C complement, I'll need to know where C complement is first, then figure out B intersect C complement. Then once I've got the first bracket and the second bracket figured out, then I can go ahead and find my big statement, A intersect B union B intersect C complement. Okay, let's get to shading. A intersect B. So these would be things that are inside of A and also inside of B. And there are 2 little shaded regions there. There's our A intersect B. C complement, everybody outside of C. So I've got all that to shade. And then finally, B intersect C complement. Where does B overlap with this last picture? So B is any one of these four regions, and the parts that were shaded in this picture are just the first two. So what I'm shading now, these are things that were shaded in C complement, which also happen to be inside of B. Okay, so I've got A intersect B, my first bracket. I've got B intersect C complement, my second bracket, and now I'm combining those last two Venn diagrams together with a union. And for a union, we're shading anybody who was shaded for either of the two pictures, shaded in one or the other or both. So I have just the B by itself, that was shaded in one of the pictures. I have the everybody, A intersect B intersect C, that was shaded in one of the pictures. And then I've got this part, this is inside of A, inside of B, not inside of C. That was shaded for both, so that needs to be shaded as well. So looks like we've got three areas that are shaded in for A intersect B union B intersect C complement. All right, same sort of thing. We've got a bunch of little steps to do for this. I would need to find where is A complement and B complement first before I can find A complement intersected with B complement. Once I've got that, then I can find what is the union with C. So once I know A complement intersected with B complement, then I will just go right ahead and find what is the union of it with C for my last picture. So let's start with A complement, everybody outside of A. So that would be all of that, and that, and that, and also the exterior. There we go, there's our A complement. And I'll do the same thing for B complement, all the things that are outside of B. And now A complement intersected with B complement. What do they have in common? The exterior was shaded in both pictures, so I will definitely shade the exterior here. And the only inside of C, not inside of anybody else, was shaded for both pictures, so I'll shade that as well. So there we go. That's my A complement intersected with B complement. And then for my last diagram, I need to now have the union of that with C. So for a union, we're shading anybody who is in the first diagram, or anybody who's inside of C, or anybody inside of both. So I'm definitely going to need all of this stuff. So all of the things that were A complement intersect B complement will need to be shaded. And then we'll also need to shade in anybody who's inside of C. I've already shaded some of it, so there's only a few other things to add in. So looks like there's 5 regions in total where you're inside of C or you're inside of A complement intersect B complement.